two examples to section 7.4, and we are going to be using the nth root theorem to solve some equations over the complex numbers. Now, looking at this equation, x cubed plus 8 equals to 0, from way back when in chapter 2, you guys actually know how to factor this over the complex numbers and come up with all of the complex solutions. Now, since it is in the form, or we can rewrite the equation in the form x cubed equals to negative 8, and then negative 8 in rectangular form, right, since negative 8 is a complex number, would be plus 0i in that a plus bi form. So since we can rewrite this equation in this form as x cubed equals to complex number, we can use the nth root theorem in order to solve for all of the complex solutions. And we know there's going to be 3 of them by the fundamental theorem of algebra. First thing that we need to do in order to apply the nth root theorem here is to rewrite negative 8 plus 0i in polar form. I think it's helpful when trying to rewrite a number, a complex number that's in rectangular form in polar form, to graph in the complex plane. So here would be my real axis, my imaginary axis, okay, and then negative 8 comma 0 would be over here, and here would be the angle theta. So in polar form, negative 8 plus 0i would have a modulus of 8, and then the angle theta we could see would actually be pi, or 180 degrees. Okay, so 8 times the quantity cosine pi plus I sine pi would be negative 8 plus 0i in polar form. So now we're ready to use the nth root theorem in order to find the complex solutions to the equation x cubed plus 8 equals to 0. I'm going to call the first solution x sub 0. So applying the nth root theorem, I would take the modulus 8 and raise it to the 1/3 power, and then I'm going to divide pi by 3. And we can simplify. 8 to the 1/3 power would be 2. And times cosine of pi over 3 plus I sine of pi over 3. So this would be the first solution in polar form. And since pi over 3 is an angle from the unit circle, we can easily simplify this to be in rectangular form. So cosine of pi over 3 is 1/2. Sine of pi over 3 is root 3 over 2. And then if we distribute the 2 in, we'll get 1 plus I root 3. So that would be the first solution to the equation in rectangular form. I'm going to call the second solution x sub 1, thinking about that index for k. So if we're thinking about applying the nth root theorem, 8 to the 1/3 power, remember, is 2. And we will take pi over 3, and we're going to add 2 pi divided by 3. And if we were in degrees, we would end up adding 360 degrees divided by 3. You could think about if you're k being equal to 1 in this case. Okay, simplify that. Pi over 3 plus 2 pi over 3 is just going to be 3 pi over 3, or pi. Okay, so that would be our second solution in polar form. And again, we can simplify here. Cosine of pi is -1. Sine of pi is 0. So we get -2 plus 0i. Oops. So that would be the second solution in rectangular form. Okay, and this solution, if we were just solving the equation x cubed equals to -8 in the real numbers, well, -2 plus 0i would be our real solution. But we're solving in the complex numbers. And x sub 2 will end up being our final solution to the equation. Now, if we're thinking about applying nth root theorem, so now we would let k equal to 2. We'd have 2 times the quantity cosine of pi over 3 plus 4 pi over 3, if we thought about letting k equal to 2. So this is thinking about applying the nth root theorem. I think that it's easier to just keep adding 2 pi over 3 to the previous angle. So since pi is the angle for the previous solution, I'm just going to add 2 pi over 3. So this ends up being the same thing. Oops, sorry. Previous angle is pi. So adding 2 pi over 3. Okay, simplifying that a little bit. Pi plus 2 pi over 3 is going to be 5 pi over 3. So this would be the third and final solution to the equation in polar form. And we can simplify. I'm going to give myself a little bit extra room by adding a page. So we can simplify. Cosine of 5 pi over 3 is positive 1/2. Sine of 5 pi over 3 is negative root 3 over 2. So 1 minus I root 3 would be the third solution in rectangular form. And if we were to plot these three solutions in the complex plane, they would have an angle of 2 pi over 3 between them. And because there's three solutions, if we were to connect, we make an equilateral triangle. So each solution has a modulus of 2. So if I were to sketch a circle that has I'll use gray, a radius of 2. So let's say that's 1, 1, 2, -1, -2, -1, -2. Okay, so each of our solutions will lie on the circle. So that first solution, x sub 0, being 1 plus root 3, that would be x sub 0. And then -2, 0 for x sub 1. And 1 comma negative root 3 would be that third solution, which we would write as x sub 2. So there's an angle of 2 pi over 3 between each of those solutions. Right, because this angle would be 2 pi over 3, then this angle would be 2 pi over 3, and this angle would be 2 pi over 3. Oops. Sorry, I said that wrong. This angle would be 2 pi over 3, 2 pi over 3, and 2 pi over 3. All right, the last example here, we're going to come up with all of the solutions to the equation x to the 6th power plus 1 equals to 0. So there's going to be, by the fundamental theorem of calculus, we know there's going to be 6 solutions here. Let's rewrite this equation as x to the 6 equals to -1 plus 0i. Okay. If we were to plot that in the complex plane, it would help us with coming up with -1 plus 0i in polar form. There's going to be a modulus of 1, and then the angle would be pi because -1 would be along the negative horizontal axis or negative real axis, plus I times sine pi. Okay, so now we can use the nth root theorem in order to find all 6 solutions. So x sub 0, we do 1 to the 1/6 power times cosine of pi over 6 plus I sine of pi over 6, okay, because we take the angle divided by 6, or n, okay, and then that'll just simplify to be cosine of pi over 6 plus I sine of pi over 6. So that would be polar form, the first solution in polar form. Cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. So plus I times 1/2. Okay, and that would be rectangular form. The second solution we could call x sub 1. And I'm going to just take that previous angle. You can think about applying nth root theorem and letting k be equal to 1. We're adding 2 pi divided by 6. The modulus is still 1. 1 to the 1/6 power is still 1. So I'll have cosine of pi over 6 plus 2 pi over 6. And I'm not going to simplify 2 pi over 6 since I'm adding the fractions, and that allows me to have a common denominator. Okay, pi over 6 plus 2 pi over 6 would be pi over 2. So that would be the second solution in polar form. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So 0 plus I would be the second solution in rectangular form. The third solution I'm going to call x sub 2. And I'm going to, you could either think about applying nth root theorem and letting k be equal to 2 so that you're adding 4 pi over 6 to the pi over 6. But that would be the same as taking the angle from the previous solution, so pi over 2, and adding 2 pi over 6 again. So that ends up being cosine of 5 pi over 6. And cosine of 5 pi over 6 is negative root 3 over 2. Sine of 5 pi over 6 is 1/2. Oops. Remember, there's 6 solutions total, so we're going to go up to x sub 5. Okay, so x sub 3. I'm going to take that previous angle, 5 pi over 6, and add 2 pi over 6. So in polar form, that's going to be cosine of 7 pi over 6 plus I sine of 7 pi over 6. And in rectangular form, cosine of 7 pi over 6 is negative root 3 over 2. Sine of 7 pi over 6 would be negative 1/2. So I can write that as minus I times 1/2. Okay, x sub 4. I'm going to take that previous angle of 7 pi over 6 and again add 2 pi over 6. So 9 pi over 6, which is actually 3 pi over 2. And then simplifying to rectangular form, cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1, so minus I. And the last solution would be cosine of 3 pi over 2 plus 2 pi over 6 plus I times sine of 3 pi over 2 plus 2 pi over 6 which ends up being cosine of 11 pi over 6. And we'll simplify to be root 3 over 2 minus I times 1/2. So 6 solutions to that equation. Not so bad if we're using the nth root theorem. Let's represent those solutions in the complex plane. So I can draw a circle that would have a radius of 1, so a unit circle. Okay, that first solution is root 3 over 2 plus I times 1/2. Which which would be the angle of pi over 3. I'll call that x sub 0. And then x sub 1 is 0 plus I. Oh no, I drew that wrong, sorry. Root 3 over 2, comma 1/2. So x sub 0, x sub 1, and then x sub 2. X sub 3. X sub 4. And x sub 5. There's an angle, so between each of those points in the complex plane would be an angle of pi over